Okay, it's 12:12. Now let's do this. So move this to chat. All right, first problem is to finish out our review of chapter 3. See if you could use the regression feature on your calculator to perform an exponential regression to get a equation for y equals a times b to the x for the following data set. I'll give you 3 minutes, and then we'll go over how to do that in case you get lost. All right. So let's go over how to do this. So stop share. We share the whole screen. All right. So what you need to do in order to perform an exponential regression is hit stat on your calculator, then edit, type the X values as your list 1, the Y values as list 2, and then stat. Go right to the Calc tab, and then you're going to need to scroll down. It's option 0, exponential regression. Enter, 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 and there you go. So y equals a times b to the x. That's the model I'm trying to find. The value for a is 88.217. The value for b is 0.914. And its correlation coefficient, r squared, is 0.998 if you round, which is extremely good. So we get y equals 88.217 times 0.914 to the x with an r squared of about 0.998. It's actually almost a perfect r squared score. So I would think that this data set is almost certainly exponential. Questions on this? Okay, let me stop sharing and reshare just the slide. All right, we have one more review question, and this goes over the stuff that you should have learned just before winter break regarding how to solve system of linear equations. So if you can solve this, then I think you could do everything that you were supposed to learn in that section. So here are 3 equations with 3 variables. You need to solve this to tell me what x, y, and z is. I'll give you 3 minutes to get started on this, and then we'll check and see how far you got. All right, does anyone have an idea of how to get started with this problem? All right, I think that means we might be, yeah, so basically the idea here is we want to try to get this down to a two values with two equations. So we want to get rid of x or y, or find out what they are, so that I can get this down to two equations with two variables, because then that becomes an algebra 1 problem, algebra 2 problem. So our first goal is to try to eliminate. Now, I know the book put a lot of stress on always like following this algorithm called the Gauss-Jordan elimination method to get it. But really, you should inspect this. By the way, that's a Z. And see if there's any variables that have the same coefficients that you could eliminate already. Because if you'll notice here, this first, second, and third equation all have 4 as a value of y. So what I can then do is if I add these two equations together, I would get 2x plus 2x is 4x. 4 minus 4 is 0. And then negative 1z plus 2z is 1z equals 12 plus 2 is 14. See that? If I add these two equations together, I'll get a new equation that doesn't have y in it anymore. If I do the same thing with these two and add them together, 2x plus 1x is 3x. Again, negative 4 plus 4 is 0. That's why we're doing this, to eliminate the y's. 2z plus 1z is 3z. And then 4 plus 2 is 6. And so using this to eliminate, we can get down to two equations with two variables. And then you have two options. You can eliminate some more, or you can use substitution method, whichever one you like best. All right, let's say, really quick before we do that, let's say that this 4 right here was a 2 instead. I could still use elimination on this. The only thing is I would multiply the third equation by 2 first to make it so it matches. So if they don't match to begin with, you can always multiply an equation so it does match. Like if all these y's were different, I can multiply this third equation by 2 so that I have all 2 x's. And then I can subtract an equation from the other two to get rid of the x's. All right, but looking at this, I think the easiest is to notice that there's a 1z right here. So I think the easiest thing to do would be to solve this equation for z and use substitution. So if I do that, I'll get z is equal to 14 minus 4x. And then I'll substitute that in for z to get 3x plus 3 times 14 minus 4x equals 6. I'm actually not going to distribute the 3. I'm going to divide everything by 3. Because I'm a rebel. I'm a rebel like that. You've probably heard that from other teachers about Mr. Lake. Oh, Mr. Lake, he is such a rebel. You got to watch out taking his class. That's hanging out with a bad crowd. you'll be knocking over mailboxes in seconds. Right, x minus 4x is negative 3x. Plus 14 equals 2 minus 14. I'm just doing math here. You're just watching me do math. Just look at me doing math. Math all day. You try to stop me from doing math right now. All right, so that's 4. Plug this in to there. Z is equal to 14 minus 4 times 4. So Z is 14 minus 16. So Z is negative 2. All right, and now that you know what Z and X is, you can take both of them and plug it back into any one of these original equations to get Y. I think I'm going to do this third equation, actually. That looks like the simplest equation. So I'm going to get 4 plus 4y minus 2 equals 4, which means 4y plus 2 equals 4, which means 4y equals 2. So y is 2 over 4, or a half. So that's my answer. X is 4, y is a half, z is negative 2. And again, if you follow the book's method, the Gauss-Jordan elimination method, that's what they're doing. They eliminate the x's from your other two equations, and then they use elimination again to eliminate the y from the third equation, and then you're substituting back in, just like we did with this. All right, happy? Any complaints? Does anybody need more time to write? Okay, well then today's gonna be a pretty easy day, I think. I think we only end up covering 3 things. We're gonna cover what a matrix is and what determines whether or not 2 matrices are equal. We're going to do matrix addition, and we're going to do scalar multiplication. Let's start with the first thing. So our goal here is to develop an idea of what matrices are and how they operate. And then once we have a good fundamentals in there, we can apply matrices to solve questions like the one we just did, 3 equations with 3 variables, a lot faster than the way we just did. And not only those, but then you can extrapolate it to 4 equations with 4 variables and solve 5 equations with 5 variables. Or if you ever want to get into economics, many of the equations that they use in that field will have up to like 7 or 8 variables. And so you have to end up solving 7 equations with 7 variables. And you have to, I mean, trying to do that without matrices is just like take forever. All right. So what is a matrix? A matrix is denoted by an uppercase letter like A, B, or C. It is it is represented by a rectangular array of numbers, where each number in here is called an element and is denoted by a lowercase that matches whatever your matrix is. So like if you were talking about matrix A, you would use lowercase a here. And then 2 subscripts, ij, where the I tells you what row the element is in, and the j tells you what column the element is in. So like this element right here, A sub 1, 2, is in the first row, second column. This element is in the third row, first column. we will say that two matrices A and B are equal if and only if two requirements. One, they have the same dimension. So they have the same number of rows, M, and the same number of columns, N. And two, all of their corresponding entries in the same position, are equal. So like if this was a 5, then the matrix B would also have to have a 5 in the first row, second column. All right. Questions about any of that? Does that make sense? I think I don't know how much you did, but I know you did some matrices stuff in Algebra 2 or honors Algebra 2. We'll see how far you went. Did any of you do anything with determinants? Okay, that's probably fair. If I had to guess, I think you probably just did like solving equations with matrices, like to find individual elements, addition, subtraction, multiplication, scalar multiplication, and matrix multiplication. If you did determinants, then you're in a good place. All right, does anyone need more time on this slide, or can we clear to move on? Okay. All right, so let's have you try it. So what I would like you to do is I have 4 matrices here, A, B, C, and D. Tell me the dimensions of each matrix and tell me which, if any, of these matrices are equal to each other. I'll give you 3 minutes. And you should be able to draw on this slide so you can label under each one what they are. All right, let's see how we're doing. Yes, that's right. Oh, got that one flipped. Oh, I think you're doing something else with it. Okay. So this first one has 2 rows and 2 columns. This is a 2 by 2. This one has 2 rows, bing, bing, 2 columns. So this is a 2 by 2. See, it has 2 rows, 2 columns. So it's a 2 by 2. But look at D here. D has 3 rows and 2 columns. So it's a 3 by 2. Remember, rows go left to right, like in an auditorium. Rows of seating go left to right. Columns go up and down. They connect, your floor to your ceiling. All right, are any of these equal? Well, D, can't be equal to any of these because it's not the same dimensions. If we compare the ones that do have the same dimensions, their first row, first column is the same. Second row, first column is the same. If we look at this, second row, first column, that's different. If we compare this to C, the square root of 4, it looks like it's different, but the square root of 4 is just 2, right? So A is not going to be equal to these, but these two aren't out of the running yet. And if we compare their last element, 0.5 is the same thing as a half. So B and C are the same matrix, just written in a different style. Yay? All right, clear this and move on? Or no? Sweet. Okay. All right, so matrix addition. How this works is if you have 2 matrices, A and B, that both have the same dimension, they both are m by n's. They both have m rows and n columns, the same number. Then their sum will also be an m by n matrix. It'll have the same dimensions. And A plus B can be found by just adding each of the elements in the 2 matrices. If the matrices have different dimensions, then you're going to write that the operation is undefined. Let's try that again. If the 2 matrices have different dimensions, then their sum is undefined. So addition works exactly how you would think it would work. If I have 2 matrices of the same size, then I can add them together. To add them together, I just add the corresponding elements together. So these matrices are both 2 by 2. So if I add them together, my answer is going to be a 2 by 2. To get the 4 elements, I just add the corresponding elements over here. -1 plus 1 will give me my first row, first column. 2 plus 3 for the top right. 0 and -1 for the bottom right. And 1 and 2 for the bottom. Whoop, I said bottom right. That's bottom left. 1 and 2 for the bottom right. If this was a subtraction symbol, it would work the same way. I would just put minus signs in place of all these, which I guess would make this one a positive. You just subtract the corresponding elements instead. So that equals -1 plus 1 is 0. 2 plus 3 is 5. 0 minus 1 is -1. 1 plus 2 is 3. So this is A plus B. told you it was going to be an easy A, didn't I? I said it's going to be an easy day, and you said, no, Mr. Lake, you say that all the time, and it's never easy. Well, look, you can't get any easier than that. All right, does anyone need more time on this slide? Okay. I could tell you, I'm not looking forward to the second semester. How we have the schedule where there's like almost no breaks. I think we get Martin Luther King's Day off and then spring break, and like that's it. Oh man. Just back to back all the way till what, the first week of June. And of course, here I'm complaining about that, but that's like how most people live, right? Most people live, they work every 5 days a week, every week, except for like, vacation time and certain holidays. Boom, 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 boom. I gotta tell you, I also don't like the order that this book chose to go in for matrices. We're gonna do 7.5, and then we're gonna do 7.7, then we're gonna do 7.6, then we're gonna do 7.4. And later, we might even come back to 7.6 because they chose to put or 7.5 because they chose to put factors in here, and it's usually something you talk about much later. All right, good to go? Good, very good. All right, your turn. Add these two matrices together, then tell me what the sum of these two matrices are, then tell me what the sum of these two matrices are. 3 minutes. If you need any help or get stuck or anything, just let me know and I'll help you out. All right, let's walk through it. So this is a 3-row, 1-column matrix. This is a 3x1 as well. So this operation is defined. The result will be a 3x1 matrix. 1 plus -1 is 0. -3 plus 3 is 0. -2 plus 2 is 0. So this is actually, so this matrix has a special name. It's called the street light. See that? Or a traffic signal. That's the right word, not street light. Actually, it has a cool mathematical name too. It's called a zero matrix. And a zero matrix is any matrix where all of its elements are 0. It can have any dimensions. It could be a 2x2, could be a 5x5, but all of its elements are 0. And it's denoted by the capital letter O. All right, part B is a 2x2. Is a 2x2. So this operation is defined. Its answer is going to be a 2x2. To find it, I add the corresponding elements. 4 plus 2, 6. -1 plus -1 is -2. 2 plus 0 is 2. -3 plus 6 is 3. All right, last one. This is a 2x3 matrix. It has 2 rows going left to right and 3 columns. And this is a 2x2. Uh-oh. Since these matrices do not have the same dimensions, then A plus B is undefined. I think, by the way, in the WebAssign, it might tell you to write impossible instead, which is kind of silly, but just pay close attention to the directions there. I forget if it asks you to write undefined or impossible. Questions on any of these problems? Does anybody need more time or clear and move on? Well, hooray. Okay. Last thing we're doing today is scalar multiplication. So how this works is if you have a matrix that's an m by n, and you have some number c, which we call a scalar, if you multiply a by c, it still gives you an m by n matrix. And to find c times a, you just take all the elements in a and you multiply each of them by c. So for example, if I want to find 3 times a, I would just take each of these elements and multiply it by 3. I just spilled coffee on myself. But I didn't spill it on the chair, maybe a little bit. All right, so let's do it. So this is a 3x3 matrix. So my answer, 3 times a, will also be, not equal sign there, will also be a 3x3 matrix. And to complete it, I just multiply each of these numbers by 3. So I get 6, 6, 12, -9, 0, -3, 6, 3, 6. We are like, I don't know what was going on with the first hour, but I think we are now 15 minutes ahead of them. 15 minutes. I think I'm going to upload this lecture to both hours instead of using that first hour lecture. We talk too much about that Gauss-Jordan elimination method. All right, does anyone need more time on this slide or clear and move on? Okay. Your turn. Find the value of each of these three. Give you 3 minutes. Then we'll go over it, and then that's the end of class. Or at least that's the end of the lecture. All right, let's walk through these. So for the first one, I'm going to take 3 times each of these elements. So 3a would be 12, negative 3, 0, 12, negative 9, 24. All right, to do this one, I basically have to do it in 2 parts. So 3a would be 3 times each of these elements. 6, 6, 12, negative 9, 0, negative 3, 6, 3, 6. And then I'm going to subtract from that each of these, the corresponding element in B. So 3A minus B would be 6 minus 2 is 4. 6 minus 0 is 6. 12 minus 0 is 12. Negative 9 minus 1 is negative 10. 0 minus negative 4 is positive 4. Negative 3 minus 3 is negative 6. 6 minus negative 1 is 6 plus 1 is 7. 3 minus 3 is 0. 6 minus 2 is 4. For this last one, you actually have two options. You can distribute this 3 to both matrices and then add them together, or follow order of operations, add them together, and then multiply by 3. It doesn't matter whether or not you choose to distribute and then add, or add and then multiply the answer by 3. I'm going to go ahead and distribute. I'm that kind of guy. So that's going to give me negative 6, 0, 12, 3 plus 12, negative 6, 9, 21, 6, negative 6, 21, 24. Yay? Any issues with that? Do you want to do more of anything that we've covered so far? Okay, well, what you should do with these last 8 minutes then is start getting to work on the WebAssign. It's only, I think, like 6 questions or 8. I forget. It's shorter than normal. So I think you could probably get halfway done before you leave class today. And if you have any questions while you're working, let me know and I'll help you out. Or if you want to leave early and just relax, that's fine too. Oh, it's 11:11. It's 1:11. Class is over. You should have had that 6th hour. I'm sorry, I got caught away in my work. Bye, everybody. See ya.